Now we'll talk about for loops. A for loop is another type of loop as well, and it is essentially a specialized type of loop. As we've seen in most of the examples, we did something X number of times. With the exception of the sentinel value one, we did something X number of times. And that's fairly common. That's pretty common in writing computer programs to want to do something X number of times. So the for loop, because this is so common, was written specifically for that purpose. It's designed to always do something X number of times. It's sort of a shortcut. It knocks probably about 2 or 3 lines off of your typical while loop to do the same thing, so it's slightly more efficient. Well, it's more efficient in general. So if we were to go back to our example where we were doing printing Java 100 times, which I think we did right here, we can do this much more efficiently as a for loop. Be fairly straightforward. Int I equals 0, I is less than 100, plus I. So what this is doing here is initializing I. You have to, we go back to the for loop, you have got to have what they call an initial action. There's 3 parts to a for loop. An initial action, the continuation condition, or the truth test under which it continues. So if I gets initialized to 0 as the initial action, and the continuation condition is I has to be less than 100, then it will continue until I is 100 or greater. And then we have the action after each iteration. So there's the, what do you do after each iteration? In this case, we're adding 1 to I. I plus plus is the equivalent of saying I equals I plus 1. So it's I plus plus. And what we're doing inside the loop is we are simply printing out welcome to Java programming. And inside the for loop, that's all we're doing. And this will print it 100 times. There it is, 100 times. So the for loop, if you remember with the while loop, we had to do more stuff. In the while loop, we basically had to do all this stuff outside of it. So I had to say int I equals 0, and then the next thing we had to say while I is less than 100, and then we had our system.out, and then I had to remember to increment I. So you can see the for loop does this, this, and this all on one line. This is also important because with the for loop, you're highly unlikely to forget to do one of those steps. Whereas with the while loop, you may forget, for example, to add 1 to I. And what that means is that you will never hit 100, and you will keep on printing welcome to Java, which is what we call an infinite loop, or a loop that never stops, or a loop that you have to force to stop, which is never a good thing. So the for loop basically takes all of that, automates all of that for you. So it's a much better way to go. So we declare I, then we declare the initializer, then the condition is true, so it stays in there. We print out welcome to Java. We increment by 1. It's still true. We print out welcome to Java. We increment by 1. It's now false. And then it exits to the next command at the end of the for loop. Right? So I could change this to 2. Run again. We'll just get it twice. Okay, any questions on this example? So the initial action in a for loop can be a list of 0, or it can be really any number. You can actually have more than one initialization. You can nest them together. I mean, this is a very complicated for loop. Int I equals 0, j equals 0, and do something complicated here, and increment both of them, and then do something. So you can actually put more than one command here. However, this is rarely done because it's not simple. And rule number 1 is keep it simple, stupid. Always in all this stuff, and that's not simple. You're also attempting to do multiple things, which you shouldn't be doing probably. You should be doing those things either inside or outside of the loop, but not in the for loop itself. So, forget that this is even possible. Just go with a standard for loop, which looks like this, with an initialization, the condition, and the iterate. What you want to do after each iteration. Also, what you can do is you can actually create a what we would call an infinite loop. You can do one if you leave everything empty. So you have the 3 conditions because that's required, but you just don't put anything there. In that case, you're creating what's called an infinite loop, intentionally creating an infinite loop. This is almost never something you want to do. There are a couple of exceptions, but they are more not in an interactive program. They are more, sometimes you might write a program that runs 24/7 because it's doing a job of some kind, what we would call. But even then, it's usually not used. So you almost never want to create an infinite loop. So you almost never want to do this. So just forget it even exists. This is a problem. For accidentally putting a semicolon at the end there is a problem. It will never do this. So for example, if I do that by accident, we'll get welcome to Java, and I can make this 1,000,000 times. We'll get welcome to Java just once. Because the semicolon terminates the command, which means this part here still exists and will execute, but it's no longer part of the for loop, so it will only execute once. See how we only got Java once? Whereas if I remove that semicolon, compile and run, now I get my 100 again. So you never want to put that semicolon there in the for loop. That's a common mistake for beginners, but don't do it. You have the same logic error in the while loop if you do it, and you can easily do that there as well. The do while loop does require it. So just to make things even more confusing, the do while loop actually does, but that's because the while and the do while is at the very end. It's the very last part of the command, and you always terminate a command with a semicolon, but just the very last part. So because the do while is the exception, because the while is at the very end, but you actually don't see it in while loops. There's no semicolon there. If we had that here, we would do all this stuff once, and that's it, instead of multiple times. So it'll run. Oh, now we're in an infinite loop. We're now in an infinite loop because it's just basically doing this over and over again. So I have to terminate it. So yeah, you don't usually want to do this. And NetBeans usually is nice. It warns you. It puts a yellow line under it. It's NetBeans' way of saying, hey, you're about to do something stupid that you don't want to do. All right. Which loop to use? There are 3 forms of the loop, and there's actually a 4th one we're going to learn about later on when we learn about arrays. That are really any one of them could do the job, but it basically comes down to this. You're going to use a while loop if you want to do something 0 to many times. You're going to use a for loop if you want to do something always X number of times. I always want to do this 10 times. That's a for loop. You're going to use a do while loop if you always want to do something at least once, but you might want to do it more times. So 1 to many times. And that's basically what you have to ask yourself. Do I want to do this X number of times? Do I want to do this 0 to many times? Or do I want to do this 1 to many times? And that question, once you answer it, will determine which loop you use. While loop for 0 to many, do while for 1 to many, and for loop for X number of times. Use the one that is most intuitive and comfortable for you. In general, any of the loops could actually work even under the other circumstances. You can make them work. So you know, as a beginner, use the one that you're most comfortable with, but eventually you want to get a little more efficient. So all of these loops are going to be slightly more efficient depending on those conditions which I mentioned. So, but in the beginning, you can use the one that you are the most comfortable with. That's all. Nested loops. Problem. Write a program that uses nested for loops to print a multiplication table. We'll look at that. So a nested for loop is a loop within a loop. We'll see how it works. So for example, and I'll show you the output first. Here's the output. A multiplication table, which has got rows and columns. This is very common. So if you think of Excel as basically a table, and a multiplication table is just that. So how do you print a table? You have to print rows and columns. A nested for loop is generally a fairly elegant way to do it. With the first for loop, generally printing the rows out. In this case, both the rows and columns are 9 by 9. So it doesn't matter that much. But if you had a difference, generally the outer for loop is going to print all of the rows. And in the inner for loop, you're going to print a column. You're going to print 9 columns. So every row you have to print 9 columns. So this prints the rows 9 times. And then within that, the inner for loop is going to execute each time. And is going to print the columns. 1 column for each row. And at the end of the row, after you print all the columns, you have to add a \n, which is a new line character. It's like hitting the enter key. So we're doing this. And we're spacing with the bar, vertical bar. So again, if we run it, we get this sort of output. Right? All these numbers across the top, if you look at it, the display starts with I, which is the row, right? And prints a vertical bar. Then it adds to it a couple of spaces, and we're saying, okay, if the value is less than 10, I times j. And the reason we're doing this is to basically keep everything together so that the spacing is correct, because we have one less space here. And then it prints that. It prints the entire row. Then it comes around, does the next row, and the next row, and the next row, and the next row. And we get our table here. Okay? Any questions on a nested for loop? And nested just means one inside of the other. And that's perfectly fine. You can do that as much as you want. You can nest them as much as you want. Generally, you don't see nesting beyond 3. 2 is pretty common, but usually not beyond 3, unless it's a real, scientific application. So if you think of nesting 2 levels deep, a table is a two-dimensional. It's two-dimensional, right? A cube is 3-dimensional. So if you wanted to emulate a cube somehow, how would you do it? With another for loop. So it would be nested 4D, 3D.